We're going to do some examples for invertible matrices. So first example is asking if this matrix right here is invertible. And there's two ways we can do this. First way involves the determinant. And the determinant of this matrix is the product of this entry and this entry. So 6 times 1 minus the product of this entry and this entry. So 3 times 2. This ends up being 6 minus 6, which is 0. And since this has a 0 determinant, it is not invertible. The other way we could go about doing this is by using row reduction. And to do that, we already have a leading 1 in that row. We're going to get a 0 here, so we're going to take R2, subtract 2 R1 from it, which will give us unchanged top row, and bottom row 0, 0. And since there's no way we can get a 1 here without getting something here, we can't get this into reduced row echelon form. Well, it is in reduced row echelon form, but the reduced row echelon form is not the identity matrix. So that means that this matrix is not invertible. Okay, so now we're going to actually invert some matrices. So our second example is we have a matrix 100, 200, 15, 6, and we're asked to find the inverse of this. So since this is a 2 by 2 matrix, we can use Cramer's rule, which tells us that the inverse is this entry, 1 over the determinant, so 1 over 100 times 6 minus 200 times 15. And sorry, this should be a 5, not 6. And then we just swap these two. So we put 6 here and 100 here. And then we just take the negative of these two. So negative 200 here, and then negative 5. So the determinant comes out to negative 400. And we can multiply this through, but we don't have to. We can just leave it in this form. That is our inverse. And now we're going to do a 3 by 3 matrix. And in this case, can't use Cramer's rule, so we're going to have to actually do this out. So we want to find the inverse of this. So we're going to have to use row reduction to do that. So we do that is we make an augmented matrix with the matrix in question on one side and the identity on the other side. And now we just row reduce. So first thing we do is we want to get 0 here. So take R2 minus R1, which gives us 0, 1, 1, negative 1, 1, 0, and the bottom row is unchanged. Then we take R3 minus R1, so we can get a 0 here. That gives us 0, negative 2, 0, negative 1, 0, 1, And now we already have a 1 here, so we're going to get a 0 there. And we do that by taking R1 and subtracting 2 of R2. That gives us 1, 0, negative 1, 3, negative 2, 0. And now we want 0 here, so we're going to take R3 and add 2 of R2 to it. That's going to give us 0, 0, 2, negative 3, 2, and 1. And now we want to get a 1 here. So we're going to scale that row by 1/2, which will give us 0, 0, 1 on the bottom, negative 3/2, 1, and 1/2. And now we want to clear the space above it, so we're going to 0 here. So we're going to take R2. Oh, we're going to take let's get this one first, top row. We're going to take R1 and add R3 to it. So we get 1, 0, 0, 3/2, negative 1, 1/2. And the other rows are unchanged. Now we just got to get a 0 here. So we take R2, subtract R3 from it, and now we get 1, 0, 0. So just do it. Okay, this row we get 1, 0, 1, and then we get 1/2, 0, negative 1/2. And now that we have the identity matrix on this side, the inverse is on this side. So the inverse to our original matrix equals 3/2, negative 1, 1/2, 1/2, 0, negative 1/2, and negative 3/2, 1, 1/2.